Hey guys, welcome to the first video of my series on regex in Python. So in this series, we are going to talk about regular expressions and their implementation or usage in the Python programming language. In this complete series, we will explore the different aspects of regular expressions, and I have chosen Python for doing the same because it provides you an easy to use interface and has a built-in library for the regular expressions. And as this is the first video, I'm gonna give you a basic introduction to the regular expressions. We are not gonna talk about the Python aspect just now. So we will just try to understand what exactly are the regular expressions, their uses, history behind them, and some basic syntax. So that is all we are gonna do in this particular video. So without any delay, let's get started. So if you have been programming for a while now, then you must have already heard about the regular expressions. So regular expressions, which are also written in short as this particular way, which is regex, or you can also pronounce it as regex. I prefer regex. So you can pronounce it anyway. The important thing is that you understand the concept. So regex is the short for regular expressions. So what is a regular expression? In very simple words, a regular expression is a sequence of characters which define a search pattern. And as we know that a sequence of character is a simple string, so basically a string which acts as a pattern for searching something in any given text can be termed as a regular expression. So this is a very simple definition that we have here. But now let us try to talk about what exactly are the regular expressions to understand it better. So the first part of this video is what exactly are the regular expressions. So a regular expression, and often called a pattern. So you can use the word pattern as well for the regular expressions. So what is a regular expression? A regular expression is an expression which can be used to specify a set of strings for different kind of purposes. So let's say you have got a set of strings, which means that you have got multiple strings which are unique. So you just put them in a set, for example, like this: file, file1, file2. So now you have this set of strings. So let's say you have a set of strings with 50 elements. Then how do you specify that particular set of strings? One normal way or one obvious way is to just specify all the elements in your list like this. So that will take a lot of space. That is not a very concise way of doing it. So a more concise way of specifying your desired set of strings is to use the concept of regular expressions, which is you just specify a pattern for your set of strings. So that is what we normally do. So for example, if I have this set file, file1, file2, then according to the regular expressions, there is a very simple pattern for specifying all the strings, which means a pattern which is in accordance with each string that we have in the set. So that pattern here is file, then you put a parenthesis in which you put 1 and 2, and then you put a question mark. So this basically means that you just put file, you match for file, then you match for 1 or 2, 0 or 1 times, which means that file is also valid, file1 is also valid, file2 is also valid. So this is basically a regular expression. We will be understanding the basics of syntax as we move through this series, but right now the important thing to understand is that a regular expression is a simple pattern which can specify a given set of strings. So let us try to check it out. So regex R is a website in which you can simply check any expression that you write, any regular expression. So this is my text file, file1, file2, and now I want to write an expression which can match each and every string in my text. So I can write file. So look at that. We are getting a highlighted text somewhere. So file, file, file in each string is matching right now, but I want to match complete string that we have here. File1 completely, file2 completely, and so on. So now if I just write file1, it will be matching only the file1 substring, right? But I want to match each one of them. So what can I do? According to regular expressions, there is a syntax in which you can just put 1, then a pipe symbol and 2, which means that 1 or 2. So I can have file followed by 1 or 2. But now I am not considering the file string, the first string, the file. So for doing that, I just put a question mark, which means that I want to repeat this particular thing 1 or 2, 0 or 1 times. So now file is also valid. So in this way, I have discovered a very simple pattern for myself, a regular expression, you can say, which can specify a given set of strings. So this is what regular expressions actually mean. So now the last thing to understand here is that the specification is not unique, which means that for a given set of strings, you can have multiple regular expressions. You can have multiple regular expressions which specify a given set of strings. So for example, in this case only, you have written this particular regular expression for your regular expression for your set of strings. So what you can do is that you can write some other expression. Let's say file /d question mark. So /d means you're talking about the digits. So /d is a character which specifies any kind of digit. So file can be followed by any digit, 0 or 1 time. So in this way, we have written a very simple regular expression, and that is also going to match each string in our set, because that is also valid. So that explains us the fact that the specification is not unique. There can be multiple regular expressions for a given set of strings. So if your friend has written a different regular expression for something and you have written a different, but both are working, then there is no need to argue. There can be multiple regular expressions. So yeah, this is what regular expressions are exactly all about. Regular expressions are actually a mathematical concept. So the concept of regular expressions originated from regular languages. So now you must be thinking, what is regular language, right? So regular expression actually describe the regular languages, and regular languages are defined in the formal language theory. So what is a formal language? That is what we need to understand first. So a formal language is actually a language which consists of words whose letters have been taken from a predefined set of alphabets, and all the words that we make in that particular language are well formed according to a specific set of rules. So you can specify those set of rules by using some kind of a math, and that is what a formal language is all about. A formal language, a language which has some predefined specific set of rules, well formed set of rules. So that is a formal language. And the simplest kind of language which comes under the category of formal languages is a regular language. So a regular language is a category of the formal languages. And what is the definition of a regular language? It's quite interesting. A regular language is the one which can be expressed using a regular expression. So basically the concept of regular expression and regular languages are complementing each other. So let's say you have some kind of language. The language can be, let's say, in your language, the alphabets or the letters that you have are all the digits, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is your alphabet set of your language, and the rule that you have in your language is that each word in your language can have only 3 characters. So it simply means that you can make the words like 0, 1, 2, 2, 3, 4, 4, 5, 3, anything like that, right? So now all these kind of strings that you can make using your this particular language can be expressed by using a very simple expression, by a very simple regular expression, which is /d/d/d. So this is a very simple regular expression that you can have, and it will be able to specify any kind of word that you can make here. So you are using a regular expression to specify any kind of word that you can make using your regular language. So that's why this is called a regular language. So this can be an example of a regular language, right? So what is a regular language? Any kind of language that you define, which can be, whose all the strings that can be formed using that language can be defined or expressed using some kind of regular expression. So that is a regular language. So in the formal language theory, each language has a grammar, and on the basis of grammar, there are 4 categories. There can be regular grammar, there can be context-free grammar, context-sensitive grammar, recursively enumerable grammar. So these are the 4 kind of grammars that we have. So this all concept comes under the theory of computation in the math domain, and that is not the focus of study in this particular series. We are only going to talk about the regular expressions, their implementation and usage in Python. So we are just gonna stop right here about the math thing. And the last thing to understand here is that today many regular expression engines are provided by the modern programming languages. So basically, if in Python you want to use the regular expressions, then you need to have a program which implements the concept of regular expressions. So we call that program a RegEx engine or a regular expression engine. So now today the RegEx engines are actually very powerful. They have a lot of features. They have a lot of features which cannot be expressed by a classic regular expression. So the concept of regular expression has got distorted a bit because of the powerful regex engines, because they have gone a bit more powerful, and they are not exactly matching with the definition, the mathematical definition of the regular expressions we have today. But that is not an issue, because we want more powerful engines so that we can do our work more easily, right? So that's why the regular expressions today are more powerful, and they can be, or they are actually more powerful than the classical regular expressions, and the math is not actually the same. Okay, so that is all about the math of the regular expressions. Okay, so now it's a time when we talk about the uses of the regular expressions. So what are some important uses of the regular expressions? So the first thing that you might have already experienced is that on many websites, when you type your email address, and if it is not following some kind of a pattern, so let's say you just write your name instead of writing a valid email address, then it shows you that write a valid email address. So at most of those kind of places, what we have actually is a regular expression which matches your input with some kind of a pattern, and if that pattern is not matching with your input, then some warning is raised. So if you want to have a kind of a situation when you want to check if some kind of input by the user is honoring a given pattern, which means is in accordance with a given pattern, then you can use the concept of regular expressions. So you can just simply write a pattern which states that there should be some alphabets from A to Z, small or capital, and after that there should be an @ symbol, and then there should be again some letters, then there should be some dot, and then there should be 3 letters which specify your top level domain. So in this way you can specify any pattern for email, or maybe for some kind of URLs, or any kind of input that you want to check. So at those places you can use the regular expressions. The second use is that you can check, you can just search for a pattern in a given piece of text. So just like we have Control F, in which you can just search for anything and we can get the result. But now let's consider a situation like in your text you want to search for the word color with 2 different spellings, COLOR and COLOUR. So what you will do is that you will just press Control F, you will first search for color, then you will just search for color in the other way, right? But what if you want to search for both the words in a single scan? So by using the concept of regex, you can search for both the words in a single scan. So that is what the beauty of regular expressions is, because you can just specify a pattern which is in accordance with both the words, right? So by doing that you can search for patterns easily. The next thing is that you can extract the specific portions of a text. So let's say you get input, you get some house address as input, and now you are asked to extract the postal code from it. So you can simply look for a pattern of, let's say, 5 or 6 digits in the address. So whenever you find a pattern of 5 consecutive digits in any given in your address, then you can just simply extract that particular part. So in this way you will get the postal code. Other than that, there is something called replacing. So you can just replace the portions of text. For example, in your text you can have you can change replace the word color or color, so basically 2 different spellings with red. So you can do that again in a single scan, so that is also easy. And other than that, you can split a large text into small pieces at all the places where a particular pattern is getting matched. So these are the different uses of the regular expressions that you can have, and all of them are quite useful when you are dealing with large amount of text, right? So yeah, so these are the different usages of the regular expressions. Now let's take a look at a brief history of the regular expressions, and trust me, it's quite interesting. So the origins of the regular expressions date back as far as 1943. In 1943, 2 neurophysiologists, Warren McLeod and Walter Pitts, actually published a paper which was titled "Illogical Calculus of the Ideas Immanent in Nervous Activity." So by just reading this title, you might not be able to understand that how does this talk about regular expressions. But actually, the paper was talking about the concept of the regular expressions, and it also proposed the first mathematical model of neural networks also, which is the basis of deep learning that you must have heard nowadays. So in 1943, they came up with some kind of concept of regular expressions, which was related to how does the brain matches different kind of patterns. So for that, they came up with the concept of regular expressions. Then 13 years later, in 1956, Stephen Klein wrote the paper Representation of Events in Nerve Nets and Finite Automata. So finite automata is actually a part of the mathematical domain, which is theory of computation, which also studies the formal language theory. So all the things are interconnected, and regular expression is one part of them. And Stephen Klein was the first person who coined the terms regular sets and regular expressions. So regular sets are those set of strings which are specified by regular expression, and regular expressions, as we know, is used to specify a regular set. And he also presented a simple algebra for the same. So Stephen Klein was the first person, or you can say the father of the regular expressions, because he coined those terms and he presented a simple algebra for the same. Then 12 years later, in 1968, the Unix pioneer Ken Thompson, the guy behind the Unix, he took Klein's work and extended it. He published his studies over it, and he didn't just end there. He also created the first editor, the first text editor which used the concept of regular expressions. So as I told you, in the uses of regular expressions, it can be used for searching for some pattern, for replacing some pattern, for extracting something, for splitting your text, any kind of things. So all those things are actually done in any kind of a text editor. So the first text editor, which was called QED, was made by Ken Thompson, which implemented the concept of regular expressions. And the aim was that the user can do the advanced pattern matching in the text files, right? So by using regex, you can do advanced pattern matching. So that is what it was all about. And then he made one more powerful text editor, which was later called ED, right? So ED is more popular. So yeah, this was the thing which made which brought the regular expressions into the mainstream. And to search for regular expressions in ED, you just write G slash, then you write some regular expression, and then you write slash P. So the letter G actually meant a global search, and P meant print the results. So this was basically the syntax. And from here, the command grep came into existence. So grep is the command which is actually used in the Unix systems for searching anything by just specifying a pattern. So in all kind of Ubuntu systems, or basically any kind of Linux system, or even the Mac system, there is something called grep or grep, which is used for matching, right? So but till then, till 1973, the grep did not have a complete implementation of the regular expressions. So in 1979, Alfred Aho developed egrep, which was called extended grep, in the seventh edition of Unix. So it took some time to create the best version of grep which used the regular expressions, and egrep was what came up. So the program egrep was able to translate any kind of regular expression to a corresponding DFA. So DFA basically means deterministic finite automata, which comes from the concept of theory of computation. So it was basically it was a complete implementation of the regular expressions. And after that, in 1987, not a lot far ago, in 1987, Larry Wall created the scripting language Perl, as you must have heard of. So Perl was the first programming language which seamlessly integrated regular expressions. So regular expressions are seamlessly integrated in Perl, even with its own literals, the variable names or any kind of string that you can write, everything has the seamless integration of regular expressions. So in this way, Perl actually pushed the regular expressions to the mainstream, and many other languages actually inherited from the concept or the way Perl used the regular expressions. So this was what brought regular expressions to the mainstream in 1987. So as you can see that in 1943 we first came up with the idea of the regular expression, and it took 44 years in 1987 to create a programming language which was seamlessly integrating the regular expressions into its ecosystem. So after that, IEEE also created their own flavor, you can say, or the syntax for the regular expressions. So basically, Perl created its own Perl flavor, which was the regular expression syntax, which they defined, and IEEE in tried to standardize the same thing, and they came up with something called POSIX flavor. So POSIX is a standard for different things which is released by IEEE, and POSIX flavor is what they came up with for the regular expressions. And also in late 1980s, Henry Spencer wrote the first software library for regular expressions in the C programming language, which was widely used. So these are some worth mentioning milestones also. So 1980s, 1990s were the days when the regular expression came into the mainstream. Every programming language tried to implement them, and in today's date, a programming language is not considered complete if it does not have the support for regular expressions. So yeah, here is a brief timeline to summarize the complete thing that happened. First of all, the idea of regular expression came in the form of a paper written by Warren McLeod and Walter Pitts. Then Stephen Klein coined the term regular expressions, regular sets. Then Kem Thompson, the father of Unix, he developed the first text editor which can use regex. Then Alfred Au developed the complete implementation of grep, which is a standalone program for regex in Unix. Basically a command which can be used in the terminal itself for searching any kind of pattern in different kind of text. And finally in 1987, Larry Wall created Perl, which was the first language to integrate regex seamlessly into its ecosystem. So this is a brief timeline going from 1943 to 1987. And what is regex doing today? So today regex has been implemented in a lot of programming language, as we can see here, and Python also supports the regular expressions by through a inbuilt library which is called RE. You can simply do import RE to import the regular expressions library, and the RE module actually supports the Perl style regular expressions, not the POSIX style. Also, there is an effort to write a new regex module with better POSIX style support. So you can say that the RE module itself is not that much extensive or complete, and actually there is a third-party library which is called RegEx, which aims to be a more better option to the RE module. So it offers additional functionality. So yeah, so this is all about the brief history of regex and what it is today. So finally, we have reached the last part of this introduction video, and now we are going to talk a bit about the regular expression syntax. So till now, what we know is that a regular expression is an expression which is used to specify a set of strings. Mathematically you can say that, but as a simple concept you can think of it like a regular expression specifies a search pattern. So what is a regular expression? It is a simple sequence of characters which you are going to use as a pattern somewhere. So the components of a regular expression or a regex pattern are basically a regex pattern or expression is composed of two things, which is literals and meta characters. So literals are basically the ordinary characters which are matched as it is. So basically when we saw the example of the file, it was file and we were writing file /d plus or question mark. Yeah. So this was the regular expression which we had seen in the first example, in the first part. So here FILE all are literals because they do not carry any special meaning, and they are processed as it is. They are simply matched one on one with the text. So those are literals or the ordinary characters. But then there are meta characters which make the regular expression powerful. So meta characters are actually the special characters which carry a special meaning and they are processed in a special way. For example, /d is a meta character. Actually slash is a meta character which when combined with d gives it a specific meaning, which is /d means that we are talking about a digit. So 0 to 9, any kind of digit we are talking about. And question mark is a meta character, which means that from the preceding character we want 0 or only one occurrence. So we simply means we can have file, file1, file2, that's all, right? So in this way we have literals and meta characters. Literals are the ordinary ones, meta characters are the special ones. So let us have a bit more extensive example now. So consider that we have got a list of several files name in a folder. So in a folder I have these 7 file names: file1.xml, file1.txt, and so on. And now what I want from you is that I want you to give me only those file names which follow a specific pattern. And what is the pattern? The pattern is that you can write file and then it can follow up with one or more digits, and then there should be .txt. So there should be file, then at least one digit, and then there should be a dot, and then there should be txt. So if I want to specify this particular thing, then how do I write a simple regular expression pattern for that? So let's try to see this with an example. So let me just copy the text that I want to match. Let me paste it here. So yeah, so this is my text which I want to match, and here I'm going to write my regular expression. So it is file. After that it can follow up with one or more digits. So for specifying the digits, you can just put /d plus /d, and then you can put a plus. Plus means there can be multiple repetitions, one or more repetitions of the preceding character, which is /d. So there can be file, then there you can have file1, file12, file123, anything. /d plus, then there could be dot, and then there is .txt. Actually dot is also a meta character, but right now I want to use it like a literal. I want to just use it without any special meaning. So if you want to use a meta character without any special meaning, you can put a backslash before it. So now it makes more sense. So here you go. So file /d plus, which means file. After that any number of digits, one or more number of digits, then .txt. So look at that, we are getting our desired result: file1.txt, file2.txt, file60.txt, file5.txt. So in this way we are able to write a regular expression. So now the important thing to understand here is that this regular expression has file as literals and .txt as literals. /d plus is the meta character here. So yeah, you should not get intimidated if you find this particular regular expression difficult, because we are going to learn everything related to regular expression from scratch from the next video onwards. This is just for representation purposes, example purpose. So here I have written the regular expression that we need. So look at that, file is a literal, /d is a meta character to match any digit, plus is a meta character to match repetition of the preceding character, which is the digits, and then this is also a literal, but it has been which is actually an escaped meta character, because dot is actually a meta character, and we have txt as a literal. So in this way we have written a very simple regular expression which is doing a very powerful task for us, right? So this was all about the basic syntax of the regular expression. We are gonna learn the complete thing by implementing it in Python from scratch from the next video onwards. So yeah, so this is all about a basic introduction to the regular expressions. I hope you enjoyed it. If you still have any doubts, you can put them in the comment section below. That's it from this video. Thanks for watching.